Thank you, Paul. Okay, so here we are in AutoCAD Civil 3D, and you can see here I've got basically a blank screen, but I've got all of these points here that have been brought in by the survey crew after they took all those shots in the field. Now, all of these points here are geolocated, fancy way of saying that they lie on a coordinate system so that they reference a specific spot in Texas. So what that allows me to do is I'll be able to drop it into a map here pretty soon. I'll show you that in a second. But also you'll notice that each of these have elevations assigned, which means that this is 460.46 feet above sea level. And that NG there stands for natural ground. There are other ones here. This is edge of curb, edge of asphalt top. They have different abbreviations for these. So we've got a road that's over here. This was down in the creek. And this cluster right over here, this is where the bridge is. And you can see those four columns kind of stacked up here, and they're even labeled COL. Now what happens here is these pieces of information can all be taken and turned into contours that allow me to build a three-dimensional surface. Okay, so here are some contours that were built from some of those shots, and I have already turned these into a surface. Now what that means is, as a surface, it is a three-dimensional entity. So even though I'm looking at it from above and it looks just two-dimensional, right, just x-axis and y-axis, all right, which we have down here, x and y, even though we have that, this is actually three-dimensional. So if I hover right here, you can see that it's telling me what elevation I am at on that surface. So that is 493.3 feet above sea level. If I go down a step, that's going to be 492 something. Down again, 491. You get the idea. These darker contours, the red ones here, those are major contours. These are minor contours. There's actually a fun feature here where I can just select this, go to add labels, add multiple, and if I just drag that along, I get these contour labels that tell me what elevation each of these contours are at. And if I want, I can select it, and I can maybe just go and make it to where it's just the major contours that are showing up there. And then I have a reference. I can tell that this is going to be in here. This is 471, 2, 3, 4, 5, right? So I can figure that out. Well, here's where it gets really cool. I can actually come up here to the three-dimensional axis and rotate this, and I can start to see what this is going to look like in 3D. Let me zoom in here. You can tell that this is actually triangulating things in three-dimensional space. It's not just a two-dimensional object. So you can see that there's kind of some valleys there and there's some ridges. So it's not like a mountainous area, but it does have elevations, and it can be seen to be 3D right here. Now where this really starts to get cool is that I can come up here to this geolocation tab, and if it would respond, there we go, select that. I can come over here and I can turn on an aerial map, and it might take a second to load here, but because of those coordinates that were plugged in with those spot shots that they took down in the field, this surface comes in exactly where it needs to be. And Bing Maps here, not that I'm getting paid to say that, Bing Maps offers us a visual overhead of what's going on, and it fills in real time exactly where we are located here. So you can see how this gets pretty powerful pretty quickly.